Okay, so one last thing, just real quick, and then let's get back into some code. Some people followed up from our discussion last class. Most of you, I would think, would want to take CSC300 in the fall. That's the programming language theory class, and if you are switching over to the new major and the software engineering concentration, for example, that class is the class where we write programming languages. We use a language called Scheme. It's fun, but you know, it's students usually at first don't like Scheme, and then they catch on, and it's kind of a fun class. But punchline is that you probably want to take that class when the rest of your programming stuff is fresh in your mind. Not that you can't take it the following fall when it's also offered, because presumably you should be doing programming throughout next year as well. But just a suggestion that if you've had, coming out of 300, you're in programming mode, 470 would make a lot of sense if you can fit it in your schedule in the fall. Okay, so let's jump back into our discussion from last week. Get my soda open here. All right, so we had decided, we went through and we kind of planned out our process, kind of a software engineering type of approach, and decided what would be the correct tools for us to use to represent our various objects. We decided that a room would have a title, it would have a collection of door objects. Since we only have, let's say, 1 to 4 doors, if we just use the cardinal directions, we thought maybe an array would make some sense, if for no other reason than to give a little variety to the various data structures we're using in this, this project. We won't waste very much memory. We only have 4 things, whatever. And then we'll have a collection of students. Some of you asked, why do we need to have more than 1 student? Well, we're going to be moving down a path where we might want to make this multiplayer, for example, or at the very least, this idea of students maybe switches to something called an inhabitant, where maybe we put like a rat or something like that into the room. So we want to have a collection of inhabitants that might be in the particular room, and that would be a linked list, since things may come and go from the room as we as the game comes to life, let's say. So that is a room itself. A door is going to have a direction leading, so a couple of strings and then a couple of rooms. So direction leading to room A, direction leading to room B, and then room A and B. We decided to, we could have gone either way. We could have a door be, we could have 2 doors, 1 door leading from room A to room B going to the north, and another door leading from room B to room A going to the south. We can certainly do that, or we can just create a single link between 2 rooms. Either solution is viable. If we are, so this kind of came down to our discussion about directed graphs last time, where if we have a directed graph, that means that every one of these doorways here, for example, is a 2-way street. We can go, I'm sorry, an undirected graph. Each of these doorways is a 2-way street. We can go from here north or from here south, because this guy does not have a direction associated with it. So that would be the model that we're currently using, where we have a single door that goes in 2 directions. There's a direction one way leading to room A, there's a direction in another way leading to room B. These directions are just a description of the directions. It's a 2-way door. It goes between room A and room B. Okay, we could certainly make the argument that we want it like that. The alternative is we can have a second door here, one leading to the north, one leading to the south, and then it becomes a directed graph. It just so happens that in our world here, all of these doors are two ways. If we imagine a room that, or a world where we might have some one ways, we might decide to implement it with a single door per direction. So you can kind of decide what makes the most sense, but at the very least, that discussion is worth having from the perspective of how do we do doors and how does that translate into graphs? Again, focusing in on this idea that, you know, we have these ideas of base data structures, but we modify them and we use the spirit of the data structure, if you will, when we are creating our own. In this case, we're effectively making a map, right? And this map is graph-esque, but instead of being nodes, it's rooms, and instead of being edges, it's doors. And doors, in our case, maybe are two-way because we're modeling the computer science department, and all those doors are two-way. So that's one way we could look at this. And then we decided a student would just have a name and then would also know what room they're in, because if we put ourselves in this world, maybe we dump them into this first hallway initially, and then they start walking their way. They can go to the west. So that would remove them from this room and put them into this room. And they can go to the north. That would remove them from this room and put them into this room, so on and so forth. Okay? All right, so any questions about the approach we're trying to take here? Hopefully all of you have spent quite a bit of time banging on this particular solution, that you've wrapped your mind around this pretty well. So then let's go ahead and take a look at it. Get my Ubuntu loaded up here. Okay, so here's our dungeons and data structures. So let's go ahead and let's revisit room here for at least at first. So again, we have for room, we have a string, we have a collection of door objects. I mentioned 1 to 4 doors here. I've implemented it as up to 10 doors. And then we have a number of doors that are in a room, because we're going to have to use this value here to let us know how far into this array are our doors. Because we don't want to access bucket 7 of an array that only, for a room that only has 2 doors in it, we're going to start getting segmentation errors. We're trying to talk to doors that don't exist. Okay, so that's what this last variable here is for. When we build a room, we're going to build it with its title, and then we will add doors after the fact. So we're going to have an add door thing in here soon, but we'll come back to that. So base for a room, it has a title, it has the current number of rooms is 0 because we haven't added any rooms to it, or doors to it rather. Okay, so then we'll go to door HPP. All right, so this guy is going to have our direction to room A, direction to room B, the pointers to both rooms. When we create a door, we're going to give it all that information. There's the implementation of that. So right now we aren't taking doors or anything. We just can build doors. Great. Okay. We created our linked list of students. This guy is going to hold our student objects that are running around inside of our dungeon, let's say. All right, and then back, and a student is right here. Student has a name and it knows what room they are currently in. And then we get to our driver currently. So we create a couple of rooms. We create a couple of doors that lead between the rooms. And that's our current state of things. All right, so what we want to do now is we want to get these doors associated with our rooms. All right, so this door right here, door 1, is a link between server room and lobby. So that's these 2 rooms right here, server room and lobby. So I want to add this door to both of those rooms. So I want both of those rooms to have a pointer to this door, because if a student is in either one of those rooms, they might take that door and show that room. So let's teach a room how to add a door to it. So we'll go into room. We'll create a void add door. This guy will take a door pointer, call it a door, as a parameter. We'll go and implement this guy. All right, and what we're going to do is we are going to add this door to this room's collection of doors. This room's collection of doors is called, let's remind me later, is called collection of doors. And the current bucket that I want to add them to is going to be whatever current number of doors is, which starts off as 0. So I'll put them at bucket 0 once. Then I need to increment that. All right, so we're going to put it in. We're going to say this collection of doors at bucket, this current number of doors is equal to a door. And then this current number of doors plus plus. I added a door, increment the number of doors. So that next time I add a door, I have more doors. Okay, so now I have the ability to add a door to a room. Now, while we're at it, maybe a room has the ability to display itself so it can show the current doors that are in the room. Specifically, we want to show, if I'm in a room, so let's go back to our map here. If I ask this room right here to display itself, it might say, I have an exit to the north, I have an exit to the east, I have an exit to the south, I have an exit to the west. This room says I have an exit to the south. Well, this door right here is the same door in both of these guys. They both have a pointer to that guy. So this guy knows that this exit is to the south because it leads to a room that is not him. Okay? Similarly, this guy knows that this room has an exit to the north because he knows that the destination is not him. And what I'm getting at there is, how does a door determine which direction to display in a particular room? It should display the direction leading to the room that is not them. So if I'm that room to the north here, if I'm this guy, and I want to display all the exits that are currently in the room. So maybe in this particular case, that guy is room B, this is room A. I'm going to show the destination for room A direction within room B, because that is the room not associated with me. All right, because we're using this two-way door. So otherwise we might accidentally say we have a direction to the north, but it still leads us to this place. Might be a little bit structurally unsound, but in computer software, it would still work. So that's going to be the kind of magic there. So let's write that logic now while it's fresh in our mind. So we'll go back into room HPP here, and we're going to add another function. We're going to call this guy display. And for right now, we'll just have him display his exits. We might increase, well, we'll have him display his title too. All right, so here's our display. And we'll go ahead and we'll say cout all right, so cout this title. And then we'll give it a little character return. All right, so now we want to determine the, so we're going to say show the potential doors. All right, so we're going to have to go through all the doors that are in this collection of doors. How many of them are there? Current number of doors. So we'll say for int I is equal to 0. I is less than this current number of doors. I plus plus. So this guy will go through all of the doors that are in the room. And for each of those doors, we want to display the exit. So actually right before this, I'm going to say cout very much mud style obvious exits. And then we'll have like north, south, east, west, whatever coming after that. All right, so I want to go through each of my doors. Now, as a reminder, what's a door? So a door has a couple of strings and a couple of rooms. Now, if I am room A, I want to display direction to room B. But if I am room B, I want to display direction to room A. So what we're going to do is we're going to build into a door. We can ask the door to let us know the direction relative to us. So indoor HPP, let's go ahead and create a public method here, maybe called string get direction to other room. And we'll give it the room we're currently in. So we'll pass the door, like we walk up to the door and we'll say, hey, tell me what direction leads to the other room. By the way, this is who I am. We're going to give them a pointer to ourselves if we're a room. So if we go back to this picture here, if I'm this guy, I'm an instance of server room. I walk up to this door and I say, let me know the direction that leads to the other room if I am server room. And he'll say, it's to the south. But if lobby walks up to that same door and says, hey, let me know that leads to, let me know the direction leading to the other room if I am lobby, it'll say, oh, it's to the north. All right, so this method is going to determine the direction leading to the other room. Whatever that other room is, we just know it's the room that's not us. All right, so let's go and implement this. Just a little if statement. All right, so again, current room is the room that is asking for the direction to the other room. So we'll say if current room, actually, yes, fine. If current room is equal to this room A, if I'm currently in room A, I want to return this direction to room B. Else, return this direction to room A. If I'm not room A, I must be room B. That's what this guy does. So he's a switch that takes in the room we're currently in, and he returns for you the appropriate string to lead to the other room from this door. That makes sense what that guy's doing? Now, I'll probably, now again, so just like before, if you've, well, you've had me for enough classes now that you've probably recognized my style. I like to give you things to grind your mind on for a while, and then I kind of show you an approach that maybe is different than you might have taken, but hopefully makes sense in the end. So the one thing that I want to point out here, and again, I'll bring attention to it, if you've noticed over the years, the way I solve problems is I let them kind of organically grow. All right. We still spend some time planning ahead of time. That's the software engineering process. You can't just dive into code. You know, there's going to be projects I can dive into that you can't quite dive into yet. And with time and experience, you'll be able to dive into larger projects. But for any programmer, regardless of level of experience, they're going to run into problems where, hey, they're going to have to spend a little time planning out what they're about to do before they just dive into code. You know, code, you can get pretty deep in the trenches in code pretty quickly. All right, so we did spend some software engineering time here, kind of planning out the players in our area. But a comment I'll make, and you've seen me put it on a slide at some point before, probably in 200. Let's see, how do I? All programs are made up of a bunch of easy parts. Now, to connect that dot there, if you look at this implemented function here, that's 200 level code, right? That's an if-else statement. Nothing special about that. The complexity of this was coming up with the idea that I could give my door the ability for me to pass him a room and him tell me the direction to the other room. Does that make sense? I gave this little ability that was easy to implement once we had the idea of the ability, and now I can use that ability within a room's display to conveniently get the direction to the other room, because my logic is encapsulated inside of door. So if I go into room now, and I'm writing this display method, here's my display method, and I'm going to go through all of my doors. What I want to do is I want to say, see out. Now I want the door at bucket I, so that's going to be this current, what is it? Collection of doors at bucket I. That is one of my doors. And I want to call that particular doors get direction to other room. And I need to let him know about the room we're currently in. The room we're currently in is called what? How does an object refer to itself from within itself?
Version?
This.
Oh.
Now this keyword. This is how an object refers to itself from within itself. I am currently in the room class. So if I say this, that is the pointer to me. So what I'm doing here is I'm saying I want to take this collection of doors at bucket I want to call his get direction to the other room, passing myself in as the room that we're currently in. Pointer to incomplete class type. That's my collection of doors. That guy is holding door pointers, is it not? He is. So that means I would use the arrow syntax here, unless it wants me to throw this in parentheses. This will be a door. In fact, if we want to make it look a little cleaner, we can say door pointer temp door. Inside here, we can say temp door is equal to this guy. That guy will be a door. And then I want to take that temp door and I want to call his get direction to other room this. Maybe I didn't save the other file. Get direction to other room. That guy should be good. What aren't you happy about? Well, we'll just keep cooking, and maybe it's something Visual Studio Code isn't happy about, or we'll see the compile error in a second. All right, so we'll go through here. We're going to go through all of our doors. For each door, we'll go ahead and grab the door, and then we'll ask the door to give us the direction to the other room given ourselves. All right, this is, we're going to pass ourself in here as the room pointer, and he will return one of the two directions depending on the direction to the room that's not this guy. Okay, so that should be our convenient way of getting that stuff for our rooms. So now after this C out, I also want to go ahead and probably put a little space here. So we have kind of like north space, south space, east space for the obvious exits. And then in the end, we'll maybe do, we'll kick it down a line. Okay, so that'll be for a room to display itself. Right now, we're only displaying a room in terms of the exits that are in that room. All right, so let's put together these couple of puzzle pieces. So we'll go back into our driver. And we have our lobby and our server room. And those guys share this door D1. So we can actually, we'll put the connections right after we make the door. So we'll say server room, add door D1, lobby, add door D1. So we added the D1 door between the two rooms that this guy, oh, actually, we don't need to add it there because we are adding it. We can do that in the constructor for our door, actually. We can do it out here. This is fine. But I actually have access to those two rooms inside of the constructor for door. D1 is an instance of door. So what I'll do here is inside the constructor for door, I'll go ahead and say this room A add door, us. So room A is the room that's in this particular class that we just set right up here. So I could also say room A and room B here if I didn't want to say this dot. So I'm going to let that room know that he has a door. And which door is it? The door we're currently building. This door. That is a door pointer. This is how a object refers to itself from within itself. So in this case, since we are inside the door class, this is a door pointer. Specifically, it's the current door. So I'm going to let room A know about this door. I'll let room B know about this door. And if you remember in rooms, add door, took a door pointer and added that to the collection of doors. So effectively, by doing that inside of the door constructor, which we have decided requires you to give it 2 completed rooms, we no longer outside in driver need to explicitly connect those rooms. I don't have to say lobby.addDoor D1, server room.addDoor D1, because the constructor for this door let the 2 guys know about this door as it was being built. That's what I'm doing right here. I'm hoping this is the same problem we were running into before. Seems to not be a fan of my door class. Door. I guess we'll burn that bridge when we get to it. Okay. So let's now go into driver, and let's try to have our lobby, this guy here, display itself. He should have directions to, I don't know, did we do hallway? I don't remember if we did hallway, but he at least should have 3 directions. Yeah, so he'll have a direction to the lobbies in all of these. So north, south, and these might be backwards. We'll have to see how we wrote those. I think it's north, south, and west. Yeah. Lobby to the north to the server room, lobby to the west to Lockler's office, lobby to the south to esports. Yep, so the lobby should have 3 things in it. So lobby, we'll tell this guy to display himself. Okay, so now let's go see what it was complaining about in those other things. Invalid use of incomplete type class room. This is a room pointer, so we'll need this to call his add door, so that's the correct symbol. This note is the thing that allowed us to handle the classes that rely on each other, so that's not a problem. Invalid of incomplete class room, so that's the same error. Same error, but related to door. Unless once you resolve something using the arrow here, then becomes a dot here. But this guy, this thing right here, if I resolve that, that is a room pointer. Pointers require the arrow to resolve the address. We could just test that real quick and see if that's the deal. Does not seem to be the deal. Let me check something here real quick. Were all of those involving this, this, and this? Every single one of those involved me passing this in as a parameter. So I wonder if the nature of this in C++ says I have to give the address. No. This is a pointer. Oh, I see what it's doing. It's saying, it's not complaining about this version of this. It's complaining about this version of this. If you see here, all these things say invalid use of incomplete type class door, incomplete type class room. So inside of here, we are in the middle of constructing this door. Therefore, this is incomplete. The class has not been completed yet. We should be able to test this, that theory here pretty quickly. I'll take those two things out for the moment. And then we have a similar thing in room. That's this guy down here. Although interesting, this is the display method. This room has already been created, yet it's still, well, here, I actually want to incomplete class door. So it's still complaining about door here, and that's in room. I give it a null value. Is that what it's concerned about? Door.
I think I had a similar issue. Go back up for a second. No, that's not it.
I mean, it's the same problem, this guy right here, where this is our room, but it's complaining out here that we have an incomplete class door.
Yeah.
But door, right now I'm inside a room, and I'm finding the door that's inside a collection of doors. So it's complaining that this variable right here is an incomplete class, even though I'm grabbing it from my collection of doors at bucket I. Collection of doors initially had nothing in it. So is this a problem of how we're passing the array around? Because this guy has a door pointer collection of doors of size 10. So I should be able to put things in there. I should be able to say collection. Oh, I'll do it over in the implementation here. Should be able to say this collection of doors at bucket 0 is equal to a new door. Here, I'll just do north, null, south, null.
We type.
Yeah, so this is the same error. Incomplete type is not allowed. So do we have an issue in our door class?
What about the room class?
Well, let's look at the door implementation first. It's complaining that it's incomplete. We've handled those. We have a constructor and a get direction to other room. We have a constructor and an implement and a get direction to other room. Those look complete. I don't have a extra semicolon at the end of that line or anything. Door looks okay. Room ends in a semicolon. We have 3 parameters: add door, display, and our constructor. Add door, display, and our constructor. No extraneous semicolons anywhere. Just comment that for the moment. Just put an extra, some logic in there for a second so it'll compile. All right, so it's happy with that. So then the question is, will it be happy with me going into driver and saying lobby, add door D1, server room, add door D1. Let's just see if it complains about those two. No, it's cool with that. So I can add doors.
I think it wasn't picking up as N and S in door CPP as actual room pointers.
Well, those shouldn't be. The pointers are the null values I passed it. But this, I mean, this was just part of my debugging. So that's not even something I really want to do. What I really want to do, so where this rabbit hole started, is here in my display method for room. I'm going through all my doors and passing myself in to this, and it's saying I'm an incomplete class, so I can't pass self in. Very interesting to me. Let's see if it's cool with that. Okay, it's cool with that. So it all has to, it all surrounds me passing this in as a parameter. Well, our hack for that, which is a crummy hack, and I mean a crummy hack. Let's just see it work first, and then we'll look up. There must be a special syntax around this keyword, like how do you pass it as a parameter? Get direction to other room. I'm passing it R now. It still doesn't like that. Oh, I need to go back out to driver. Because in this case, I would say lobby, display, lobby. Pass himself into the display function. So he would come in as a parameter instead of using this. Get direction to other room. String, get direction to other room, takes a room pointer. String, get direction to other room. What don't you like there? Pointer to incomplete class. Let's just Google that real quick. Oh, really? Oh, you forward include, and then you fail to include the header in the CPP file. Yep. So it's saying that where I said classroom here in door, I need to include room.cpp. Sorry, room.hpp. And similarly, in room where I have forward declared my class, I need to include door HPP. Yep. It didn't know about this function. It knew that there existed a class called door, but it didn't know about the function because I didn't include the header file for door. So I should be able to go back to this now and get rid of my ghetto solution here. And then go back to this, get rid of that ghetto solution. Go back to this. Now I should be able to add my doors. This guy no longer needs, oh, he does need to know the current room. And then in driver, I no longer need this. All right, so we get our lobby, but then we're getting in our, so we're past the first problem. So we get our lobby, and then as we're going through our loop inside of a room, So our issue is inside of here. Add room or add door does increase the current number of doors, and we are saying less than that. So the problem is definitely in here. Let's just prove that real quick. Okay, so that is where the problem is. Oh, my little debugging code there where I put the I++ in there so my loop did something. I think it's going to work now. There we go. And if I did that a little quick for you, if you remember when I was debugging this before, when I had everything inside of the loop commented out, this would actually throw a warning saying that this code doesn't do anything. So I threw I++ in there as just like, this loop now does something. Well, I was artificially changing the value of I by 1 before I tried to access it. And so for something that only had one room or one door in it, I was actually getting, well, actually, I was trying to access one door past the final door the very last time through. Hence the segmentation fault. So I had forgotten to take out my last piece of debugging code there. All right, so now my lobby has obvious exits to the north, the west, and the south, which seems to line up. Well, here, let's do it for the other ones too. So that's lobby. We'll do server room. We'll do esports. And Locklear office. Okay, so now I should have my full mini map. So lobby, northwest, south. Server room has just to the south. Esports has just to the north. Locklear's office has just to the east. So I think that correctly maps out that little world right there. Okay. So pretty interesting there, actually, how, well, actually, let's use that as a teaching moment. So the idea here is, if you remember back when I first introduced Java, the beginning of 250, and we talk about how one of the problems of C++ is that, well, we might say one of the problems of Java is that it hides a lot of the details from us that we would otherwise have to do. So here in C++, in order for rooms and doors to know about each other, we had to forward the class room to inside door, and we had to forward the class door inside of room. Those two things had to happen in order for this to for this code here to work, for it to know about these things, since there was a if I do a include door.hpp up here, when it tries to create this, it's going to be a circular, it's going to be an infinite loop where it just keeps creating each other over and over again. So in order to get past that, we had to forward the class here, which says, look, there is a class called door. That's all I'll tell you, is that there is a class called door. So this syntax is cool. Trust me. But what we weren't doing is over here in room CPP, we weren't saying, hey, here is, well, actually, room, yes, a door. Here are the methods that doors know how to operate on. Now that you've gotten this far, we're actually in the implementation side of this. The methods you can rely on from doors are available inside of HPP, so you can look that up. So the point is, with Java, all of that is hidden from us. If we have rooms and doors in the same package in Java, they know about each other without us doing any sort of class forwarding or includes or anything like that, because it makes them available within the same package. It's doing all of that stuff behind the scenes for us in Java so that we didn't have to. That makes some sense? So sometimes a knowledge of Java, we get a lot of conveniences out of it, kind of like the automatic transmission, but we don't have an appreciation for what's actually happening under the hood. So we were getting to the point where we knew about doors, but we weren't getting to the point where we knew about door functions. That's where we needed to import the HPP. Okay. Questions about that?
I kind of have a question in general. Like, do you think that as computers get faster and faster, that languages like C and C++ might become obsolete because our computers will just be so fast that the little slowdown from Java won't make that big of a difference?
I think maybe the answer is going to be no. It won't be obsolete. It'll be just less commonly used. There will always be some problem that requires ultimate speed. So, you know, I don't know, it's just the human version of things. Fast is never fast enough, right? So there is always going to be certain problems that require as much speed as we can possibly get. And even if Java can do can solve the problem 99.9% of the time in fast enough in mission critical things like, I don't know, rocket launches and stuff like that, you know, that 0.1% of the time isn't something they want to screw with. So I mean, I think you're right in the premise that modern languages will become more and more prevalent. We've already seen that, right? You know, Java and C# are king today, where C++ is still used, but a lot of the jobs that are out there, those of you who are already doing job hunts and internship hunts, you probably see C++ fairly well represented in terms of desired skill sets. But the reason it's desired is because you're maintaining a system that was built, you know, some number of years ago. So rather than spending money to rewrite it into modern language, they want people who can come in and work on the current code base to keep it going. So, I mean, I think that's going to become less and less common. But if you use history as an example, you know, I've mentioned several times my wife's a COBOL programmer, which is a very, very, very old language that nobody is creating new projects from scratch today in COBOL. Yet it's still one of the highest paying computer science jobs out there, because all of the people who know COBOL are dying. They're retired and now they're dying because they're old people. So, you know, now we have a resource that's needed and not enough people to fulfill it. So that's probably your evidence. COBOL today is probably like what C++ will be in a decade, something like that. Or sooner, but let's just say a decade. That's probably safe. All right. So we have our little system here of rooms and doors, and we've proven that they all kind of link to each other. Now we want to be able to add a student to one of those rooms. Now inside of room, currently, we have a collection of doors, but we also want to have a linked list of students. Now, a linked list of students, let's see, does this guy have a circular relationship? I think we're okay. So I'm going to include linked list of students. And we're going to have a linked list of student pointer called the students. And then inside of our constructor for room, we'll go ahead and initialize that guy. This dot the students is equal to a new linked list of students. Okay. Real quick, I'm just going to compile this. I want to know whether or not we have a circular relationship with our linked list without me investigating it. I'll just compile and it'll tell me pretty quick. I think we're okay. Basically, I was asking the question, do I need to class forward a linked list here? So rather than going and looking at 10 files, I just compiled it real quick and see if he complained. So doesn't look like I have to class forward that. So now I have a way of storing students. Now I have to have a way of adding students to a room. So we'll say add student, and this guy will take in a student pointer, a student. Now in order to have a student pointer, oh, I forwarded student because rooms, why do rooms need to know about students already? I don't think they do. I'm going to take that off for a second. I'll add it back in if we need to. I'd rather have the correct stuff in there than redundant stuff. So I'll go ahead and implement add student over in room. Oh, and by the way, we'll say that I did it on purpose, but I didn't. I think all of you have recognized that, you know, the tricks I used in 200 don't work as later you get into the thing, but hopefully that reinforced this idea that programming is the skill set, the language doesn't really matter. I bumped into something that seemed to be weird. I didn't know how to solve it right off the top of my head. I did a quick Google search, said, oh, that makes sense, and integrated it. That was based on programming skill, not on deep knowledge of C++ or deep knowledge of Java or deep knowledge in something else. So it hopefully, again, proves the point that what you want is that skill in programming, because you're going to, as new languages come out that you didn't learn in school, you're going to have to go in, or in my case that I haven't worked with in 30 years, are going to have to, or haven't worked with commonly in 30 years, you know, you're going to have to be able to look at documentation, look at references, and quickly come to a solution. You saw once we finally Googled it, how, you know, the first little things is, oh, that makes sense. So again, this reinforces the language doesn't matter. Learn programming as that skill set. Adding a student is going to be as easy as taking my students, and what did I call it? Add front, good enough. So we'll add our student to the front of that linked list of students. Okay, we'll leave it at that for right now. Let me just do a quick compile since I also just added student in there. Yep, we're still good. There was not a circular dependency on students. Then let's update a rooms display to not just show obvious exits. Now let's have it show also here the students that are in there. So we'll say for int I is equal to 0, I is less than this dot the students dot, what does it get, count? So we'll go through all the students in our linked list, and each time through we'll go ahead and get student pointer temp student. We'll say temp student is equal to this, the students get at index I. That'll get me the student, and then I'll go ahead and do a cout temp student what does it get name? That's the name of the student. Followed by a space. We'll prepare for having more than one student, even though right now we only have one student in there. And then we'll go ahead and do our cout \n at the end to kick it down a line. So we have improved our implementation to now let rooms also actually hold collections of students and actually display the students that are in the room. We'll go ahead and go into our driver. I did already build a student here, Mr. Gonzales, but I have not actually added him to any of the rooms. So what we'll go ahead and do here is we'll say lobby, add student, the student. So we'll put him into the lobby at first, and then we'll tell all the rooms to display themselves as we did before. So here's our, also here, Mr. Gonzales in the lobby, but notice none of the other rooms have anybody in there, but they do have an also here section. Okay, so now we want to get the mechanics of moving a student from one room to another. We want him to be able to leave the lobby and add himself to another room going through a door. So to do that, why don't we write inside of room something called take door string direction. And remember, a door has a collection of doors in it. So Mr. Gonzales might try to take the door to the north. If we go back to our picture here, if he's in the lobby and he tries to take the door to the north, it's going to have to go through the lobby's collection of doors. So it's going to look at these 3 doors and find which one has a door to the north. And then go to which one has a direction equal to north, and then follow it to that room, removing Mr. Gonzales from this room and adding him to the next room. So we're going to implement take door. Okay, so now we have our take door. So first of all, before we start removing him from the current room, we want to make sure that he gave us a direction that exists. So we're going to go through our rooms. All right, so we're going to say or our doors rather. So we're going to say door pointer temp door. We'll start that off as null for int I is equal to 0, I is less than this current number of doors, I++. So we're going to check all of our doors, looking for the one that has a direction equal to this, presuming it has one. And actually, I'm not going to, I don't need to initialize it to null here. It does get initialized to null, but I know I'm going to set it to a value. So I'll say temp door is equal to this collection of doors at bucket I. So now I have a door. So now I want to be able to see, does a door have a direction? I'm going to pause this for a second. And I'm going to be a little granular about this. So we're going to say bool. That's in the CPB. HPP. has direction. Yeah, I like doing it this way. So we'll implement has direction in here for door. And has direction is going to go through and see if either of the directions match up to the direction we're asking about. So we'll return direction to room A equal direction, or direction to room B equal direction. And I'm pretty sure the double equal sign in the string class for C++ works. Where if you remember in our lesson in Java, this actually compares this memory address to this memory address. Since we are passing around literals, it actually should still work. It would work in Java, but we're not actually comparing the contents of these strings. In this case, I believe that the double equal sign is implemented, that it does look at the contents. It's what's called overloaded. The double equal sign operator is overloaded for strings to work by looking at the contents of these strings, not just the memory addresses of them. We'll confirm that as we go through there. So we're going to ask whether it has a certain direction for a door. And then we will, if it has a certain direction, then we'll go ahead and take door, string direction, and this guy's job will be to remove, we'll figure out which door, which direction is associated with which room, and then ultimately remove the player from this room and add him to the other room. All right, so when we take a door, we will head in a direction, and it's going to add a player in that direction. So let's actually, I'm going to change this to get door. I like that better, and that'll give me a better reminder for next class. So once we know there is a door, we will get the door in that direction. So for right now, I'm going to give myself an error message right there. And then similarly in room, I will give myself an error message right there. So that'll remind us where to pick up next time, because we have a couple of nice little error messages that are sitting there. I'll go ahead and push this code so you can review it if you want over the weekend. Like I said, I won't give you any homework over the weekend, but I do encourage you to go through and update your code to for bugs you may have run into related to this. But you know, keep up on these things, but I'm not forcing you into spending time in case you need to catch up on family stuff. Questions, comments, concerns, bribes?
Thank you, Grandmaster.
All right, everybody have a good weekend.
Thanks.
When are we going to do the online belt promotion?
Well, that has to happen after the end of the semester. We don't know who's going to fail and who's going to pass.
So it has to happen at the beginning of next year?
Well, no, we could do it after the end of the semester, like before the summer starts.
Okay, sounds good.
We'll mail the belts out.
Yeah.
I don't know if I ever asked this or if anyone's asked you this in our classes, but where does the origin of awesome fat come from?
Oh, you haven't heard that story?
Maybe I have, but maybe I'm just forgetting. Like, what inspired you to like put that name as like your main online alias?
That was my TV name. I used to be a professional eater.
Right. So did you just made that up when you became a professional eater? You're like, yeah, I just need a cool name, so I'm just gonna go with Awesome Fat, or was there some sort of
fat? Awesome
okay.
Fat.
I mean, I figured it was probably something simple, but I didn't know if there was like some sort of.
That was my TV name when I did the professional eating when I was working on my PhD, and then I retired from that. I figured, hey, let's attach that to a software company, and it's always it turns people's attention, right? And
Yeah.
I used to drive around in a big SUV with Awesome Fat logos all over it, so I called it the Fatmobile.
That's awesome. That is just awesome. You know what the game Rocket League is?
Yeah.
I've been getting into that lately, and I think there's an actual Batmobile. I want to see if I could somehow change it and just have a fat symbol right on it so I can represent the Fatmobile for you.
Is that game fun? I've been thinking about trying it.
It's a game that it's like anything else. Really easy
Isn't it basically Mario Kart soccer?
Kind of. I don't know if I would call it Mario Kart as much, because really all there is for pickups are boosts, and it's a game that's easy to learn, hard to master, because there's really only 4 buttons. You have your gas, you have your boost, you have your brake, your jump, and that's pretty much it. So you really